Hi everyone, welcome to Ignite classes. Today we are going to solve one of the NCERT problems from chapter 4 of the class 12, that is moving charges and magnetism. So we can move to the problem now. It's a simple problem. In a chamber, a uniform magnetic field of 6.5 goes. 6.5 goes given 1 goes equal to 10 raised to minus 4 Tesla is maintained. An electron is shot into the field with a speed of 4.8 into 10 raised to 6 meter per second, normal to the field. Explain why the path of the electron is a circle. Determine the radius of the circular path. Okay, so what's the problem? In a chamber containing uniform magnetic field of 6.5 Gauss, an electron is shot with a speed of 4.8 into 10 raised to 6 meter per second, normal to the field. And they are asked to explain why the path of the electron is a circle, and we are asked to find the radius of the circular path also. Okay, so it's a question based on Lorentz force. So what is this Lorentz force? Yes, we know that the force acting on a charge which is entering into a region containing perpendicular electric field as well as magnetic field with a velocity v, it is equal to q into E plus V cross B. Okay, this is Lorentz force. Suppose there is only magnetic field and there is no electric field, that is E is absent there. Okay, so then the magnetic force acting on that charge, that is equal to Q into V cross B. That is, when there is only magnetic field and no electric field, this Lorentz force, it get reduced to magnetic force. So F equal to F magnetic, that is magnetic force equal to Q into V cross B, where V is the velocity of the charge particle that is uh, entering to that region, and B is the magnetic field. Okay, so in this question they had given that an electron, the particle is electron here, and electron is entering into a region containing magnetic field in a direction normal to the magnetic field, that is magnetic field as well as this velocity of this charge, they are making an angle of 90 degree, that is magnetic field and velocity, they are perpendicular to each other. So in this board I had marked this into marks to denote that this magnetic fields, they are going inward. Okay, so and the velocity vector, that is the velocity with which this electron is coming, is perpendicular to this magnetic field. Okay, so we have this equation to find the magnetic force, that is F magnetic, that is equal to Q into V cross B. Here Q will be sine 90. Since this V vector and B vector, they are perpendicular to each other, Q will be sine 90, that is Q will be. And once this charge, that is electron, enters this magnetic field, it will perform circular motion, because of what, this magnetic force, that is QVB, provides a suitable centripetal centripetal force required to maintain that circular motion. Okay, so that's why this charge entering this magnetic uniform magnetic field performs this circular motion, because this magnetic force itself provides that centripetal force to maintain that circular motion. That is, what is centripetal force? I'm writing this with Fc. So centripetal force, that is equal to mv square by r, and we know that this magnetic force, that is equal to qeb. So centripetal force for that circular motion is provided by this magnetic force. It means that centripetal force, that is equal to magnetic force here. Okay, and using this relation we have to find what, the radius of that circular path that the charge q, that is the charge of this electron, yes, it take place. Okay, so Fc that is equal to F magnetic, centripetal force that is equal to magnetic force. So mv square by r that is equal to qvb. Here we can cut one v. So what remains? mv by r equal to qb. That is r equal to mv by qb. So in this question, they asked to find the radius of this circular path taken by the electron. That is, this in this question, they said that the electron is entering a region containing magnetic field, and the velocity of this electron is perpendicular to that of this direction of this magnetic field. Okay, so and this electron performs the circular motion. First question is, explain why the path of the electron is a circle. Yes, we got the answer for that, because the magnetic force experienced by this charge, magnetic force itself provides the centripetal force required to maintain that circular motion. That's why this charge, this electron, this particle electron takes and a circular path when it enters a uniform magnetic field. Then the second question is the radius of that circular path. Here it takes a circular path, then what's the radius of that circular path? That is r equal to mv by qv. R equal to mv by qb, where m is the mass of the particle, here mass of the electron. We know that mass of the electron that is equal to 9.1 into 10 raised to minus 31 kilogram. Okay, then what is the velocity? Velocity, it is given in the question, that is velocity of this electron. That is, the electron is shot into the field with a speed of 4.8 into 10 raised to 6 meter per second, they are saying. So the speed that is equal to 4.8 into 10 raised to 6 meter per second. Okay, then explain why the path of the electron is a circle, that we had explained. Then determine the radius of the circular path. That radius, also we know that that radius that is equal to mv by qv. And what is the charge of the electron? Yes, charge of the electron that is equal to 1.6 into 10 raised to minus 19 coulomb. So we have to substitute everything here. That is m that is equal to 9.1 into 10 raised to minus 31 into v 4.8 into 10 raised to 6 divided by q 1.6 into 10 raised to minus 19 into b. What is b? B, it is given that 6.5 goes. So 6.5 and 1 goes equal to 10 raised to minus 4. 6.5 into 10 raised to minus 4. That is r equal to 9.1 into 10 raised to minus 31 into 4.8 into 10 raised to 6 divided by what? Q 1.6 into 10 raised to minus 19 into B 6.5 goes. That I said 6.5 into 1 goes equal to 10 raised to minus 4 Tesla. So Tesla is a SI unit of this magnetic field. So we should convert it into Tesla. Okay. Now we have 16 and 48. That is equal to, that is 1.6 and 4.8. We know that 60 into 3, it is 48. So 4.8 by 1.6, that is 3. Okay, then 9 into 3, this 9.1 we can approximate it to be 9. 9 into 3, 27. 27 by 6.5 we can approximate it to be 7 into, then what remains? 10 raised to minus 31 is the 10 raised to 6 the. So 10 raised to minus 31 minus 6, what it is? 25. So 10 raised to minus 25. And we have 10 raised to minus 19 and 10 raised to minus 4 in the denominator. So it is 10 raised to minus, yes, 23. So it goes up. So 10 raised to into 23. Okay. So 10 raised to minus 25 into 23. That is 10 raised to minus 22. Okay. So what is 27 by 7? 27 by 7, find it. Yes, it is approximately 3.8. Okay, 3.8 into 10 raised to minus 22. This is the answer. That much meter. Okay, so R equal to 3.8 into 10 raised to minus 22 meter. This is the radius of the, yes, radius of the circular path, that is the starts that is this charge q taken. Okay, so in this, when this charge enters the magnetic field, that is uniform magnetic field B, yes, charge, which charge is entering, yes, negative charge, that is electron is entering. Hmm? It will perform a circular path, and what we had find is the radius of that circular path. Okay, so that's all about this question. So we can do all the problems in the NCERT through this Ignite classes. So if you really likes to follow this class, then subscribe the channel, and if you like the class, please mark the like button, and it will be just like marking your attendance. So we can meet with the another interesting class. Okay, thank you.